In this video, we are going to be talking about some of the properties of exponents. Before we begin, we need to understand what an exponent is. An exponent is a quantity that shows the number of times a given number is being multiplied by itself. An exponential term contains a base and a power, which is also known as an exponent. In this example, we have 2 times 2 times 2, which we can also write as 2 to the power of 3, which is equal to 8. In this example, 2 is the base, that's the big number. 3 is the power or the exponent, it is the small number in the right-hand corner. The first property of exponents that we are going to discuss today is a product of powers. In this first example, we have x cubed, which is x times x times x, times x squared, which is x times x. Now you should notice that we have 5 x's being multiplied, and we can write that as x to the 5th. In our next example, we have 2 times 2 times 2 times 2, or 2 to the 4th, and then 2 times 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 2, or 2 to the 8th. When we multiply that all together, we have 2 to the 12th. I would like you to look at, we have x to the 3rd and x to the 2nd. We are adding those exponents to get x to the 5th. The same is true in our example using the 2's. So our rule for product of powers is to multiply, I'm sorry, I said that wrong. The rule for product of powers, well, where we are multiplying is to add the exponents. The mathematical way to say that is x to the m times x to the n is equal to x to the m plus n. Please notice that in this example, the bases are the same. So when we look at the next example, we have v's, but we also have a y. We want to make sure that we are adding exponents for only the same base. So this would be v to the 3rd, or plus 5, and then y to the 7th. Then we simplify by adding those exponents to get v to the 8th, y to the 7th. In the last example, we're going to draw it out so that you can see what is happening. We're going to do 3 times x times 2 times x. Well, 3 times 2 is 6. They are not the same base, but we can still multiply them together to get 6. And then we have 3 x's, so we are going to write that as x to the 3rd. The next thing that we are going to talk about is quotient of powers. In our first example, we have 5 x's being multiplied in the numerator, and in the denominator, we have 2 x's being multiplied. When we have x divided by x, we can cancel that to equal 1, and I'm going to do that twice. So in the end, I have 1 times x times x times x in the numerator, which is x to the 3rd, and then I have 1 in the denominator. I can write that as simply x to the 3rd. In the next example I have here, we have x squared in the numerator and x to the 5th in the denominator. I'm going to follow the same process as before by crossing out the x's and canceling them to 1. On the top this time we have 1, and in the denominator we have x to the 3rd. So I'd like you to notice that when the x's have a bigger exponent in the numerator, our answer is a numerator. And when we have a bigger answer in the denominator, our answer has the variable in the denominator. The rule for quotient of powers, as you may have seen, is to subtract the exponents. We can write that mathematically as x to the m over x to the n, which is equal to x to the m minus n. Our last example is slightly different. We can look at our x's and see that we have more x's in the numerator. We have 4. In the denominator, we have x to the power of 1. Well, 4 minus 1 is 3, so we have x cubed in the numerator. And then I'm just going to rewrite 6 in the numerator and 2 in the denominator. We can divide 6 divided by 2 to get 3, and our final answer is 3x cubed. The last thing that we're going to talk about today is the property, the exponent property of 0. Anything to the power of 0 is 1. So x to the power of 0 is 1. Y to the power of 0 is 1. 2w in parentheses to the power of 0 is 1. Please notice on this last example, 5 is to the power of 1, not to the power of 0. So here we have 5 to the power of 1, which is 5, times 1, because r to the power of 0 is 1. And when we multiply those out, we get 5. Now you may see some fractional examples where they are following either the 0 property, the quotient of powers property, or the product of powers property. Please note that the rule remains the same regardless of whether the exponent is an integer or a fraction. If you are multiplying, you just add the exponents, so you would add the fractions. And if you are having a quotient or dividing, you would subtract the exponents. That doesn't matter if it is a fraction or an integer.